Hi, and welcome to my presentation on motor learning through dynamic systems and the use of constraints and external feedback on intermediate Olympic weightlifters. This presentation is for St Mary's University, module SAC 7103, Biomechanics and Skill Acquisition in Strength and Conditioning. We need to establish what a skill is. So a skill is an ability to do an activity or a job well, especially because you have practiced it. Skills can be broken down into cognitive, memory retention, memory grouping, and analytic ability. Perceptual, speed of perception, prediction, selective attention, and response selection. Motor, dynamic balance, whole body coordination, dexterity, rhythmic ability. In weightlifting, skills would fall into motor patterns predominantly, although cognitive and perceptual abilities will play a part within this sport. There has been a lot of talk around in the acquisition of skill around Gladwell's hypothesis of 10,000 hours of deliberate practice to become an expert. There is evidence to suggest that practice does indeed increase the skill of an athlete or a performer, as true learning effects are those that endure over time or changes in conditions, the relatively permanent acquisition of skill, understanding, and knowledge. Erickson et al. In most domains of expertise, individuals begin in childhood with a regime of deliberate practice designed to optimize the improvement of skill. This is where the 10,000 hours comes from. But as we know, athletes very rarely demonstrate the exact same skills or technical efficiency. Individual differences, even among elite performers, are closely related to the assessed amounts of deliberate practice through their youth. Many characteristics once believed to reflect innate talent are actually the results of intense practice extended for a minimum of 10 years. Whilst learning these skills, how do we develop them? So Fitz and Posner put together a hypothesis of 3 stages of motor learning. In these stages, you travel through differing amounts of understanding of the movement. In the cognitive stage, this is the understanding stage where you process the information on how to perform the movement. You have the most improvement of performance in this stage, but you are very inconsistent. In the second stage, the associative stage, movements become more fluid, reliable, and efficient. Some parts of the movement are controlled automatically. In the associative stage, you begin to understand the movements and you fail them a lot less frequently. In the autonomous stage, movements become more accurate, consistent, and efficient. The movements are largely controlled in the autonomous stage. This isn't a linear progression, so you might go backwards and forwards through different stages for different movements. Successful learning of motor skill requires repetitive training. Once this skill is mastered, it can be remembered for a long period of time. This was from Luft and Buitrago. Olympic lifting is a very complex skill. It requires great intramuscular coordination and requires high rates of force development. For this reason, understanding it as a skill and how to develop an athlete's skill level within these sequences is essential for injury prevention and the successfulness of a movement. Olympic weightlifting can be designed as a motor skill because it's a learned ability of a predetermined movement outcome. Motor learning is relatively permanent change in the ability to perform a skill as a result of practice. It's also a closed skill. Closed skills are not affected by the environment. So in weightlifting, especially competitive weightlifting, the platform where an athlete lifts is the same. The bars are all standardized, the weights are standardized, and nothing really changes. So weightlifting is a closed skill. There are obviously some differences maybe within gym setups of independent clubs, but largely most gyms will have a solid platform, standardized bars and standardized weights. It's also a discrete skill because it has a definite beginning and end. You start with the weight on the floor and you end with it above your head. Of the two lifts of Olympic weightlifting, the snatch and the clean and jerk, the clean and jerk falls more into a serial skill. So you have the clean and then you have the jerk. The clean is a discrete skill and the jerk is a discrete skill. But in Olympic weightlifting, you put them both together to make a serial skill. So you get the weight from the floor to your shoulders, and then from your shoulders to above your head, turning it into a serial skill. Olympic weightlifting is largely a gross skill. It uses large muscle groups to power through the floor and get the bar above your head. This does require fine motor skills and precise movements to keep the bar where you want it to be. You don't want the bar floating away from the body too much. In dynamic systems theory, the first look at how we will develop the skill, it's quite spontaneous in the coordination of systems. An athlete is basically told, you've got to get the bar from the floor to above your head, and the athlete will self-regulate everything else that happens in between. The athlete will get more stable over time, and the movement will get more consistent, but they will travel through many unstable states and create high degrees of variability or freedom within the execution. This process can be highly ineffective using dynamic systems alone and requires a lot of guidance from a coach for self-organization, which makes achieving the learning of the task challenging. There is a low retention rate for the information within the athletes. Stability and adaptability does come over time, but without guidance, the athletes will fall back into the original movement patterns. From dynamic systems theory, there is high degrees of freedom. There are multiple ways for you to accomplish the task or the outcome. Degrees of freedom relates to these variabilities. Reducing the variables increases the efficiency and the success of a desired task. Mechanical degrees of freedom are designed as a minimum number of independent coordinates needed to describe a system's position or where the bar is in relation to the body. How can we limit the degrees of freedom without taking away an athlete's self-regulation and the exploration process in developing a skill? We can apply constraints. Constraints are specific factors that remove certain movement solutions. So for our athletes, we want to limit the degrees of freedom that they have without limiting their self-exploration. These constraints must be applied from an analysis of the sport and the athlete's current movement solutions. The self-organization process is still present as a solution shouldn't be presented to the athlete, only the problem. Constraints are there to eliminate actions or diverse solutions, influenced by constraints put upon them. Adding a constraint doesn't have to make an action more complex or difficult. It can be, if the constraint takes away the easiest and most attractive movement solution, but we're not there to make things harder. We are trying to narrow the potential solution options by eliminating solutions that aren't effective for the problem. Task constraints are applying rules to a movement. Some of these rules can be, you can't jump your feet forwards onto these plates, you can't jump your feet out wider than the plates. But the constraints need to be appropriate for the sporting skill that you are trying to create. What are the rules of the sport? Are we going to be breaking the rules by applying some of these constraints? They need to be carefully considered before we start applying them. Remember, we are just trying to help find a movement solution, not prescribe a movement solution. It should only guide the athlete. These constraints need to be athlete specific. Individual constraints can help an athlete retain the information specific to the task. Practice should be as similar as possible to competition to generate validity of the movement and transfer of the skill. How we design these constraints will help with this massively. Adaptability within the athlete will come from the tasks and the constraints, and how well the athlete adapts will depend on how we have designed them. In baseball, they managed to increase a batter's accuracy by constraining batters to hit above a post to get a high ball. Environmental and individual constraints are the other two factors we need to consider. Environmental constraints shouldn't affect Olympic weightlifting too much. As we said, the platform is standardized, the weights are standardized, the bar is standardized. The location will be different, so there may be some weather constraints to deal with, but apart from that, everything else should be relatively equal. The individual constraints come from the height, range of movement, and the body weight of the athlete. Comps may place a constraint on the athlete where they need to be below a certain weight, so these need to be considered throughout the training process. Environmental constraints are very rarely manipulated by the coach, but you could play around with some of the constraints, environmental constraints in training if you really desired, by changing the surface or the temperature or restricting sight or sound from your athletes. With constraints, you can use external feedback. So external feedback is feedback from an external source, which is provided by another person or computer, and feedback that is added to a task environment. In strength and conditioning, this will be provided by poles, plates, walls, and other external objects. Visual targets can be used, as we said with the baseball study, using a post to bat above, but this will be very dependent upon the sport. Feedback, external feedback shouldn't really be verbal, although it can be from a coach or an athlete. First-hand feedback for the athlete is a really good source. If they are hitting a post in front of them, and they shouldn't be, they know they are letting the bar drift away from the body. If we give verbal feedback too much, we start to drift into the reverse learning method. Okay, so in the reverse learning method, the teacher would, or the coach would, teach you the outcome, and then you would work back from there. This is a very common in strength and conditioning practice, but it becomes a very coach-centered approach, as the coach will determine when you move on to the next movement. These tend to have negative effects on performance linked to this approach, and there is an increased reliance upon the coach from the athlete. For discrete coordinative skills like Olympic lifts, research supports whole body practice methodology, like the constraints method. Reverse learning, sometimes known as the top-down method, creates a limited understanding of the movement for the athlete, and therefore the athlete becomes highly dependent upon the coach. Breaking the skills up into small sections or decomposing the skills alters the proprioception, the visual perception, and the horizon feedback on the movement. So it changes the actual perception of the movement for the athlete, so there is not much carryover into the original lift. There is little evidence around supporting this as the best way to use this methodology. Some of the reasonings behind using this methodology is believed that athletes block information. So there was a study done on grandmaster chess players where they presented boards, and they had to recreate the boards that they'd just seen. So for normal chess movements, they could recreate the boards because the pattern was similar to them. If they were presented with a problem that was not in their normal repertoire of chess layouts, they couldn't recreate the problem. So they recognized the sequences of what was on the chessboard, not what was actually in front of them. So this is where the reverse learning method sort of creeps in. They learn a block, but if anything is different from the block, it won't recreate over into the actual movement. In summary of everything, research is light, and the field of skill acquisition draws on motor control, neuroscience, motor learning, and experimental psychology. In strength and conditioning, there is a lacking of focus on the development of skills. The research suggests that coaching practice that follows whole movement approaches as opposed to the decomposed reverse learning or top-down method, being an athlete-focused approach, has higher degrees of retention and transferability to competition. Thank you for watching my presentation. I'll just go through the references for you.